Hello, in this video I would like to show you how to safely connect a breadboard to a Raspberry Pi. Obviously there are tons of tutorials on YouTube showing how to work with a Raspberry Pi and a breadboard, but there's generally an issue with them I would like to address first. The typical approach is, in many, if not most of the tutorials I've seen, that they use jumper wires such as these to make connections from the Raspberry Pi to the breadboard. On the surface, this is very sensible, especially for beginners. A wire like this has two different connectors at the ends, which makes it easy to use. You take one side of this wire and connect it to the chosen header of the Pi, and take the other side of the wire to the breadboard. You can have up to 40 wires like that, depending on the size and type of your project. I cannot think of a single reason why this is a good idea to do it that way. Let me give you some of my thoughts why this is a bad idea. Most of all, this creates a tangled mess. Wires like that may work for a trivial project, such as blinking an LED, but beyond anything like that, you would be using dozens of such wires to the breadboard that is simply not workable. Also, every time you make changes to the circuit, you always need to power off the Raspberry Pi, and this is both not practical and time-consuming. The GPIO header connections are hard to see and close together, and it is very easy to be off by one pin. You are actually risking damage to the Raspberry Pi. Yes, the Pi will be turned off while you're making the connections, but eventually you will have to power it on to test your circuit. I concede that in many cases nothing bad will happen, but why take the risk? If you are using those jumper wires, it will take you longer than it should to build your circuits, especially if you need to find that one wire that does not work. The breadboard itself will have many wires, and adding more is the last thing you want. Every wire you eliminate makes your life easier, and you should always have a goal to use as few wires as possible. Projects built like this are not very portable, and they are hard to preserve. If you are working on a circuit and would like to put it aside to work on something else, you will have to disconnect everything while keeping detailed records of the wires, and when you come back, you will have to reconnect all of them. You can take photos, make little labels on the wires, but this is so much work. This is why I do not use these wires. My preference is to use a cobbler connector, something that looks like this. They come in different sizes and configurations, but generally they have the same idea, to give you a nice, neat package to connect the Raspberry Pi to the breadboard. A cobbler and the Pi is coupled together with a 40-wire ribbon cable that looks like this. And you're replacing up to 40 loose wires with a ribbon that has all these wires together. This is nice and rigid and stable, and that addresses all the problems I just spoke of. Cobbler connector is very simple and quick. You start with the breadboard itself and place the cobbler in the middle of the breadboard. Depending on the cobbler size, it may or may not center. This is not really that important. You can start with row 1 on the breadboard, but if you don't like that the cobbler sticks out, you can move it a little bit. Once you have it aligned, you just push it down into the breadboard, and you leave it permanently. This way you don't wear out the breadboard every time you take it in and out, as these pins are quite thick. The ribbon cable is connected next. There are notches on each connector end, helping you align and connect it correctly. There's one on this side, and there's one on the other one, upside down. You can make the breadboard connection in two ways. Either go like this, but that way the ribbon gets in the way. I suggest connecting it the other way around. This way, you will have the breadboard all uncovered and the ribbon cable doesn't get in the way. Make a corresponding connection on the Raspberry Pi side. Unfortunately, there is no notch, and it is therefore possible to connect it wrong. You need to pay attention how the cobbler matches the Pi headers. There are two rows, left-hand side and right-hand side on the Pi, and the same matching rows must be connected on the cobbler. This must be done correctly, otherwise you connect it upside down, and that will lead to miswire and possible damage to the Pi. This is assuming that you did the connection earlier like this. The ribbon flows away from the Pi and then goes straight towards the breadboard connection. If your Pi is in a case and your cable is new, it might be hard to make the connection because of the right angle. You can bend the ribbon cable as needed. Align the connector carefully, making sure that you get both rows. Otherwise, you will see the connector sticking out on one side of the connector. Align the connector and push it in. Make good contact. Make sure that you have it all the way down and make sure you don't see a row of missed headers. I suggest leaving the ribbon permanently connected to the Pi. This case has a ventilation gap under the lid that fits the cable nicely, and you can actually keep the case closed. When I build my circuits, I have breadboards disconnected. I put my components in, double check the connections, and when I'm confident it's all fine, then I connect the breadboard to the Pi, while the Pi is powered. If I want to make changes, I make sure to stop the running program. Then I grab the ribbon and wiggle it a little and disconnect it from the Pi. Then I make my changes. I do not shut down the Pi in the process. The key is to make sure that your program is not running and the components are not being controlled at that time. If they are de-energized, it should be safe to disconnect the ribbon. Now, where to get this ribbon and cobbler? There are multiple vendors on Amazon that sell Raspberry Pi kits. I have linked in the description to one of them. I have nothing to do with the seller and I don't get paid for promoting them. I just like what they offer and I bought from them in the past. You can remove the cobbler if needed. You can pry it off with a flathead screwdriver, making sure that you don't bend the legs. As far as the building of the circuit itself goes, the nice thing about the cobbler is that it gives you a legend of available pins. This way you don't have to keep on hand a printout of the GPIO pins. Everything is laid out here so you know exactly what each connection is. For example, this row here is GPIO 21. While this row here is ground. You can use these holes to provide starting points to your circuit. Generally, you do not put any elements in this area next to the cobbler. This is only to make connections, jump off points, and all your elements such as resistors, LEDs, or whatever you're using would be in this area of the breadboard connected by wires. Let's say you would like to ground the power rail here. Find any available ground connection and connect it to this power rail. If you would like to wire up an LED, for example, place it somewhere on the breadboard and use a resistor to connect it and limit the current. Then finish up the circuit, connecting the other side of it, connecting the LED to the ground. You shouldn't put the resistor anywhere here, even if it might seem convenient. This is not meant here for components, it's just for starting connections and providing power. There's lots of room here on the breadboard to build even complex projects, as long as you're smart about it. I hope this was useful. If you're just starting out, that will be my suggestion, and buy a kit that has the cobbler. If you have been working with Raspberry Pi with the wires, perhaps I have convinced you to give the cobbler a try, and I have a feeling you will not look back. If you liked the video, please subscribe, and I will make more. Thanks for watching.